Hi, welcome to the Read With Me series, Yojana Special Issue, October 2021, Science and Technology. The article is Technological Advancement, Geomagnetism Applications by Praveen B. Gawali. Geomagnetism has many societal applications, and this science impacts all of humanity in one form or another. The very survival of all the life forms on Earth is interminably related to the existence of this geomagnetic field. Efforts are being made to use it for an early warning system of natural disasters, including earthquakes and tsunami. A significant contribution to research in the field of geomagnetism started in the 19th century. The magnetic field, since it originates inside the earth and travels through its different constituents and materials, turns into a handy tool to peer inside and examine it. Some of the material attracts electromagnetic wave towards it and some resist. The delineation of electromagnetically conductive and resistive bodies can help earmark sources of natural hazards or natural resources. The antiquity of the Indian Institute of Geomagnetism goes back to almost 2 centuries, and it is a force to reckon within field of geomagnetism and allied research areas. It has earned a great reputation of being one of the best in the world with consistency in innovating new and advanced research. It is a global leader in magnetic and electromagnetic data collection. This data is eagerly sought by pioneers the world for their geomagnetic research. Geomagnetism is a global phenomenon, and hence it cannot be understood in isolation or locally. The research areas that are covered by Indian Institute of Geomagnetism encompass a wide spectrum. On one hand, it explores the interior of the earth, and on the other, it vast boundaries reach the sun to understand its dynamic. If it explores different layers of the earth, it also investigates a gamut of atmospheric strata. If it uses seismic waves to unravel the earth's property, it also harnesses radio wave to ensure seamless communication. Out of the sun, earth, or the dark space between these two entities, none have been left unexplored by Indian Institute of Geomagnetism. A set of magnetic instruments way back in 1841 were to be installed at Aden, Yemen. However, because of some unforeseen circumstances, those instruments had to be installed at the Colaba Meteorological Observatory. A separate enclosure was constructed and the magnetic observations were started. But Colaba Meteorological Observatory had to be shifted to Alibag in 1904 because the growing urbanization was hampering magnetic readings, especially when the electric tram started its operation. It is practically possible to shift a magnetic observatory from one location to another and still retain the consistency of variations. This consistency was established by simultaneous measurements at Colaba and Alibag for almost 2 years, from 1904 to 1906. The recordings have been continued at Alibag since then and formed a continuous Colaba-Alibag Magnetic Observatory data series. This data is treasure trove that contains within it a range of dynamic phenomena that has been unraveled and continues to do so. The Indian Institute of Geomagnetism was given a separate and independent mandate in 1971. India had started its exploration into space research. It needed specialized personnel to study geomagnetic phenomena. There was also a growing expectation of fully comprehending the diaphanous domain of the Earth. This is done by generating data at meteorological observatory, carrying out periodic surveys, collating data, which is accumulated and assimilated by the scientists at the headquarters, regional centers, and quite often at the meteorological observatories as well. The magnetic minerals embedded in crustal rocks are harnessed to map Curie temperature symptomatic of the crust mantle magnetic transition zone. They are also used to understand the regional deformities and structural framework of the continental and oceanic realm. The mineralized zones and geotectonic fault categorization become easier with remotely sensed magnetic data. The composite magnetic anomaly map developed at Indian Institute of Geomagnetism is in the league of its own. The expert in the field can mine a wealth of information regarding the regional geology and tectonic framework of India. Magnetic minerals play a very important role in understanding climatic changes and environmental fluctuations. These minerals are quite stable in the unchanging physico-chemical domain, but are quite sensitive to the changes in those circumstances. They alter themselves to maintain equilibrium with the surrounding. Laboratory investigations reveal the degree and phase changes in magnetic mineralogy, which can then be associated with a climatic or environmental process. The solar magnetism impacts celestial entities, which include Earth as well. The energetic particles emanating from the Sun influence Earth's magnetosphere, ionosphere, mesosphere, and thermosphere. Solar flare, coronal mass ejections, high-speed solar wind, and solar energetic particles are the manifestation of dynamic flux. The Earth is also a magnetic, and the genesis of this field is theorized, modeled, and simulated to be at the core mantle boundary. The field lines traverse through different Earth layers to protectively blanket our planet. This is the shield that stops and deflects harmful radiation. Life and electrical communication are thus maintained and sustained. The interaction of these charged particles with the atmospheric constituents creates aurora at the polar regions. These curtains of light are especially more active and prominent when a magnetic storm hits the Earth. Solar wind emanates and flows continuously throughout the space in all directions. The Earth experiences it, however. The recording of its interaction and creation of electromagnetic current in the atmosphere are carried out at the meteorological observatories. The complex interplay of heat and energy at the surface of the Sun and its atmosphere creates a temperature dichotomy. The wave and particle that originate at the solar domain travel outward at incredible speeds. To tackle this diaphanous domain, an eclectic approach is pursued to unravel the complex forces that include gravity waves, infrared rays, ultraviolet radiation, and other perturbations, along with the high altitude winds that blow ions across the Earth's magnetic field by creating a dynamo. All these forces causes collision between neutral charged particles, enabling them to exchange charge to transfer energy and momentum amongst them. The end time and the duration of the solar cycle are also attempted over here. It is now dawning on the expert that solar energy fluctuations can have an impact on temperature dynamics of the Earth. The atmospheric tides are global scale variations in wind, temperature, and pressure tied to solar input. They occur throughout the atmosphere on a regular basis and are seen once or twice daily, with small tides at frequent interval. The tides move westward with the sun, driven by the solar radiation, its absorption and re-emission various heights. These processes are active even when the sun is inactive or quiet. But there is a crescendo of events where there is a solar storm. The cataclysmic burst of charged particles and radiation completely rearranges global thermospheric circulations in a matter of hours. The ionosphere and magnetosphere are a closely coupled system that channels energy and momentum from the solar wind to the upper atmosphere. A number of coupled current systems flow in these regions of highly conducting plasmas. These currents are responsible for most of the temporal changes in the geomagnetic field that occur on timescales of seconds to days, including magnetic pulsations. Studies of the ionosphere and magnetosphere seeks to obtain a quantitative understanding of the flow of energy and momentum through the solar wind, magnetosphere, and atmospheric ionospheric systems. This study in turn supports the physics magnetic reconnection at the magnetosphere. The response of the magnetosphere to changes in solar wind pressure, the processes responsible for viscous-like interactions. Investigations towards this direction elucidate the physical mechanism responsible for generating pulsation and controlling their cross-field transport in the magnetosphere. Plasma encountered in the Earth's as well as other planetary magnetospheres are generally far from their thermodynamic equilibrium states and hence contain some amount of free energy. These free energy sources can generate several kinds of plasma modes in the magnetospheric boundary layer, such as a magnetopause boundary layer, plasma sheet boundary layer, polar cap boundary layer, etc. Magnetic minerals also tell us about continental migration. Before the era of GPS, paleomagnetism was the only reliable and accurate technique to understand the direction and quantum of the plate movement. The concept of polar wandering and magnetic reversal baffled the geoscientist. The realization of the presence of magnetic banding in the oceans ultimately led to the formulation of the concept of plate tectonics and seafloor spreading. It revolutionized the way scientists thought about the investigating natural resources. The plate boundaries and the faulting zones were found to be the ideal candidates for mineralization. Paleomagnetism tied all the diverse and distinct plates with the grand continent Pangaea and its later subsidiaries like Gondwana Land and Laurasia. The dynamo that generates the magnetic field of the Earth and how it operates is now fairly known and clear. The reversals that are generated are recorded in the rocks and sediment containing magnetic minerals. These polarity reversals and the normal polarity of the Earth are used as a relative timescale to date the rock and sediments. The other geophysical techniques like gravity, electricity, seismicity, and GPS have shed light on many unknown aspects of the crust and mantle. In a bid to be ahead of the evolution curve, Indian Institute of Geomagnetism strive hard to be the best in the business by thinking within and out of the box for optimum utilization of its available knowledge base. The long series data that Indian Institute of Geomagnetism has at its disposal is is of immense significance. It has the data related to solar processor, Earth processes, the magnetosphere and the atmosphere containing ionosphere. It became a foregone conclusion that combining the data from these diverse yet connected realms will highlight new insight and novel perspectives that were not thought of earlier or considered possible. The multidisciplinary studies have brought out the interdependence of certain processes within the crust and ionosphere domain. The earthquake generated waves while traversing the subsurface or surface perturb the atmosphere. This perturbation sends shock waves into the atmosphere through the ionosphere. These waves straddling the surface and the atmosphere can be used to understand the dynamics of seismicity. The year 2021 marks the golden jubilee of the foundation of Indian Institute of Geomagnetism. In 1971, it was set on path to glory and given an independent mandate to pursue geomagnetic research. Nature Index ranking has placed Indian Institute of Geomagnetism amongst the top 10 research institutes of India pursuing fundamental research in earth science. To sum up, geomagnetism, earth magnetism, is an ever-changing entity because of which it has to be monitored and recorded continuously. It is a vital research in the field of scientific technology, allowing us to get more familiar with our planet and the solar system. Thank you.